I am not wearing shoes right now. So today I'm going to talk about superposition. I don't know if you've noticed, but this is the third topic in circuits that has super as the prefix. I think there must be something to this. Either circuit theory is really cool, or electrical engineers are just trying too hard. Now, if you think of the supernode, the super loop, and superposition, and add to them Georg Ohm and Gustav Kirchhoff, it's like we're forming a superhero team like X-Men or the Avengers or the Mystery Men. Maybe we should come up with a name for this, like the Electro Avengers or the Electro Team. Leave your appropriate suggestions in the comments. To get to the point, let's talk about superposition. I'm sure you've seen superposition in other areas if you're an engineering student, but we're going to talk about superposition as it relates specifically to circuits today. What superposition tells us in circuits is that if there are multiple sources in a circuit and we're looking for a specific voltage or current related to some element, then that specific voltage or current is equal to the sum of the contributions from each source taken independently, that is, with all the other sources turned off. That's a lot of words to kind of piece together, so let's try to digest this a little. Let's say that I have a circuit and it has both a current source and a voltage source, and I'm looking for a voltage across a specific resistor. This could be a problem. It may mean nodal or mesh analysis or something more terrifying. What I'll do first is I'll turn off the current source and I'll find the voltage that is due to the voltage source. Then I'll turn off the voltage source and find the voltage across that resistor that's due to the current source. Then I'll add them together, and their sum is going to be the total voltage. An analogy that's really easy to understand is the situation where you're on the highway and traffic is merging down to one lane. The number of cars that go into that lane is equal to the sum of the contribution from each of the lanes. Of course, this usually makes life less easy, but superposition is aimed at making life more easy. One important consideration is that when I turn off a voltage source, it's going to become a short circuit or a wire, and when I turn off a current source, it'll become an open circuit. To understand this clearly, let's do an example. In this example, I'm going to use superposition to find the voltage across the middle resistor. I'll start with the contribution due to the 1 amp source, which means I need to turn off the 10 volt source or replace it with a wire. I redraw the circuit and try to find the voltage across the central resistor, which we will call VR1. Then I notice that the two resistors on the right hand side are in parallel. Combining these resistors, I get 1 ohm. Then I can use Ohm's law to find the voltage VR1 is equal to 1 volt. Next, we look at the contribution due to the 10 volt source, which means I need to turn off the current source or replace it with an open circuit. I notice that the resistor on the left hand side is connected in series to an open circuit, so there is no current going through it and no voltage drop. As a result, the resistor can be removed. Then I can use voltage division to find the voltage across the resistor in question, called VR2. This voltage is 5 volts. Now that I have the contribution from both sources, I can add the result together to get the final answer, which is 6 volts. So, as you can see, we can break down a potentially difficult problem into small, easy problems that use things like Ohm's law and voltage division to find our answer. This makes a good case for the inclusion of superposition on the ElectroFolk Super Team. Thank you so much for watching this video. If you think I've earned it, I would love it if you would subscribe and share this video with someone else. You can find me on Twitter or Instagram at BD McPheron. This is Dr. McPheron. Have an Electro Super Day.